So let's discuss now how to define variables in MATLAB, how many different type of data formats that you can use in MATLAB, um, how to represent data in different formats in MATLAB, and then we're going to move on to evaluate equations, evaluate functions in MATLAB. So in the command window, you can do, as I said, you can do a lot of calculations, you can define variables, you can evaluate simple functions. But when you're writing a program in which you have to do things sequentially, then of course you're going to be using your editor to write the program. And once again, for homework, you have to use your editor, write a program for all the homework exercises that you will be doing from the tutorial, and then you're going to be submitting the files that you're going to be saving in the editor on Canvas. So as I define variable v over here, assign a value 3, that's how you define variables in MATLAB. First, you're going to create a name for the variable, which is comprised of letters and numbers. And the only special character that you can use is underscore. You cannot use any special character when you're defining a variable. You cannot use a period, or you cannot use a hyphen. Only underscore you can use as a special character when you're defining a variable. The other condition on defining a variable is variable, they have to start with a letter. You cannot have them start with a digit or underscore. So it has to start with a letter, either uppercase letter or lowercase letter, it doesn't really matter. But it has to start with a letter, and then it can contain numbers, digits, and special character underscore. Now, uh, if you use uppercase letters and lowercase letter, that will be considered as two different variables in MATLAB. So you can define lowercase w e3, or you can define uppercase w, lowercase e, assign it a value of 2.6, or you can define uppercase w, uppercase e, assign a value of 1, 2, 3, 4, 5.67, and observe that it changed the value into exponential form, which is one of the default formats to represent the values in MATLAB. Now observe that it dropped 7. It dropped 7 just for the representation purposes, but the complete value is still stored in the variable uppercase w, uppercase e. So just for the representation purpose, it's not showing that value, but it is there. So all these variables, although all of them are v, but they're different variables. To see the list of variable, you can use a function who, and it's going to show you that these are the variables that are present in MATLAB memory right now. And then to get further information about different variables, you can use a function whose, and it's going to show you that these are the variables, this is the size of variable, how many bytes these variables have, and then what is the class of the variable, double, single, exponential, and all those things. So this is how you define variables, as simple as that. Now you can represent the values in different formats. So in your tutorial, if I go back to, since we are on the variable, let me just mention one more thing. All the discussion that I did about variables, that is, they have to start with a letter. They can only contain a special character underscore. They can contain numbers. So I can define a variable, for example, QWERTY 1234 underscore 9, and assign a variable 435, something like that. So that's a perfectly good variable name. There's nothing wrong with that. Whatever applies on the variable name, on variable's name, the same conditions apply for the file name as well. So make sure when you're saving your file in the editor, your file name should start with a letter. It can contain numbers, but the first character should not be a number. So the first character has to be a letter, uppercase, lowercase, whatever you want to do. and again, it can only contain the special character underscore. So that's why I ask you to save your file name as your first name underscore last name underscore ex for exercise, and then the number. Don't use the number sign. Those don't use the hashtag, because that's not an acceptable character that you can use while assigning a variable or while assigning a file name. So just do ex1 or ex2, whatever, but do not use either a dash or a sign, a number sign. So whatever rules applied on the variable name, same rules apply on the file name that you will be saving. Now, different formats to represent numbers. And again, you can read the tutorial. I'm not going to go over everything, but I will be showing you many things from the tutorial. These are different number formats right here. So by default, you have short G. That's a default format. It's the best of fixed or exponential floating point with 5 digits. So whichever is the best to show. If the number is very long, then it's gonna round it off and show it as an exponential number. Or if the number is short, it's just gonna show you the short number, but it's gonna use only 5 digits to show the number, whichever format. And then you have just a short. So if the number is short, the default format is short, floating point fixed with 5 digits. If the number is long number, then it's going to be exponential form, and then it's still going to be 5 digits, but it's going to show it in the exponential form. So you can see your assigned values or values that you collect from results by evaluating equations or anything in the short format, which is the default format, short G or short, long format, which is 15 digits, and then 7 digits for single class and 15 digits for double class. Then you can have exponential, short exponential or long exponential, and then you can have short engineering and long engineering. And I hope everyone know about the difference between the engineering exponential format and the scientific exponential format. If you don't, then engineering exponential number is basically the power of the exponent is a multiple of 3. So the power can be 0 and the positive powers multiple of 3, that is 3, 6, 9, 12, or negative multiple of 3s, that is -3, -9, -12, -6, so on and so forth. And for each exponent values, then we have the uh, corresponding format, or not format, corresponding type for that. Like for example, 10 to the power 3 or exponent 3 is the kilo, and 10 to the power 6 is mega. And likewise 10 to the power -3 is milli and micro and stuff like that. So in engineering, of course, we don't really show a huge number like 0.0000000357. We tend to write the numbers in the engineering format. So 3.5 exponent -9, and then we replace the exponent sign actually by the type that we assign to that exponent, that is either milli or mega or whatever the number is, whatever the exponent power is. And of course, the engineering not the engineering, scientific format or the scientific notation is that there will be an exponent sign, but exponent power can be any power, and there will be a decimal after the first digit. So there will always be a decimal after the first digit, and then based on how many numbers are in the original, how many digits are in the original number, it will set the power of the exponent after putting the decimal after the first digit of the number. So you can set how the number will be represented in MATLAB. That does not mean that MATLAB is going to calculate in those formats. No, MATLAB is going to calculate the complete number, and it will save it as the complete number. I think it's I believe it's 15 digits total, or maybe more than that. I don't remember exactly, but it will save the number but it can show you the number only in the format in which you want it to show. Again, if you don't choose any format, it's just going to show you, but that in the default format, which is short or short G. But you can set, for example, if I want to see the numbers in engineering format, so I can set format, let's say short ENG. So it's gonna be short ENG, which is right here, floating point exponential with 5 digits, engineering notation. So for example, if I want to see the value of it's already in exponential engineering format, by the way, but if I want to see a value of, let's say, 4564892.8765, so observe that although I write that big number, but since I chose the format as a short engineering format, so it showed me 35.6489 exponent 6, or 35.6489 mega. So this is how you can set the format, and you can do the same while writing a program. When you're writing a program, you can just set format, whatever format you want to use from that table in the tutorial. You can just use format and then short ENG, long ENG, or just format short, long, or any other format. To go back to the default format, if you don't want to use the format that you are in, you can just type format, and it's going to take you to the default format, which is the short G or short. Um, Another thing is how to clean up this command space. To clean up this command space, you can just write down CLC, clear command window, and then it's going to clean up the command window. Now that does not mean that the variables that you assigned, they're lost. As long as you don't clear those variables, they will still be in MATLAB memory. So if you type who, you can still see that these are the variables that you have assigned, all of the variables. Observe that there's a variable called ANS, or answer. So if you do not assign a variable to a value, or if you are performing a mathematical operation and you do not want to save that operation, the result of that operation, in a variable, you can just type that operation, and then it will be assigned to the default variable, which is called ANS. So if I type ANS, it will keep the value that was assigned into it without any variable. And then anytime you do an operation and you don't assign the value in a variable, then it is going to be assigned to ANS. The old value is going to be deleted and the new value will be assigned to ANS. So make sure anytime you want to keep a value, make sure to assign it to a variable. Let's see what else. So you can perform basic mathematical operation. For example, oh, by the way, I showed you how to clean the screen, but if you want to delete a variable, if you want to clear a variable, then the command is clear. And then let's say if I want to clear variable WE, then clear WE is going to clear that variable right here. And in the list, you see that WE is no longer there. If you want to clear all the variables, just type clear, and it's going to clear up the memory of MATLAB. Clear is very important actually, and I will advise you to use it when you're writing your program. Start your program many times, start with a clear command, so that if I have some, for example, I'm grading different students' work, and if you're using the same variable as some other student was using, and his values are already sitting in my MATLAB memory, it is possible that when I run your program, it will take those values and then it may start giving me incorrect value, or it starts giving me error for your program, although your program may be written um, in a correct way. And many times it had happened, especially when you're dealing with vectors and matrices. So if that happens, of course, I go to the program, I check your program, I see everything looks good, and then I go ahead and I clear memory on my side, and most of the time it works properly. But it may not be a bad idea. It may be a good practice if you add the clear command when you start your program. So when I run your program, it is going to clear up my memory, and then your program is going to run without any problem. Usually it runs without any problem, but it does happen every now and then that it start importing the values from the other student variable if you're using the same variable, especially again, as I said, if you're dealing with vectors and matrices. So that's clear. Okay, basic mathematical operations. Um, we have basic multiplication, asterisk, division sign, addition and subtraction by their signs, and the power is this. So for example, if you want to perform an operation, you want to do, let's say, uh, 2 times 3 plus 6 times 7 divided by 5 square. So 2 times 3 plus 6 times 7, and then since this is a numerator and you want to evaluate the whole thing, make sure you have to use the parentheses as you use in mathematics. So this, anything that is inside the parentheses, that will be evaluated first, and then anything that is outside the parentheses is going to be evaluated, divided by, let's say, 4 square. 2 times 3 plus 6 times 7 divided by 4 square, which is 3. Now if I don't put parentheses, now another thing, do I need to write this equation since it's already there? Remember I told you about the history. History can also be recalled by using your arrows on your keyboard, your top arrow and your bottom arrow. So if I press my top arrow, it's going to go back to one step in the history. So it's going to recall the last thing that I wrote in the command window, and it comes very handy. Like right now, I didn't want to write the whole thing again, so I just pressed that, and the last command appeared in this on the screen. So for example, if I remove the parentheses here and remove the parentheses here, then what's going to be the result? The result is going to be, it's going to multiply 2 times 3, it's going to multiply 6 times 7, and then 6 times 7 will be divided by 4 square first before it is added in 2 times 3, which is a standard mathematical operation. Remember that in mathematics and arithmetics, anything that is written in the parentheses is evaluated first, followed by multiplication and division, whichever comes from the left hand side, and followed by addition and subtraction. So if you make sure you put parentheses properly, and if your parentheses are mismatched, if you forget about it or if you put extra parentheses, it will show you in the editor. If you're doing it, it will show you, actually it will show you a red mark, and then when you run your program, it's going to give you an error. It's going to show you the parentheses are mismatched. So MATLAB gives you actually very good information about errors if you make errors in your program. But anyways, if you write a question like this, then the result is going to be 8.6250, because now 42 6 times 7 is divided by 8 first before it is added into 6. Okay, so let's see what we should do now. So let me go in the next video. Let me go ahead and we will do equation evaluation, and then I will show you some of the basic functions that are present in MATLAB that you can use.